Okay, this is also lesson 4.7 in algebra. This is lesson 4.7b. We're going to talk about piecewise-defined functions. All right, what they look like is this. It would say this. You're going to need to graph these, by the way. This is all graph paper. I guess all right. This is what the question would say. It would say to graph f of x equals, and then they have a system here. It looks like this: negative 2x if x is greater than 1, and then x plus 3 if x is less than or equal to 1. Okay. Let me try to explain this to you, all right? I need you to see something here. The important thing that you see is that I have two slope-intercept form lines right here staring at me. I have two slope-intercept form lines staring at me. They're right here. There's one, and there's two. I need you to see them. F of x equals, what if I had this? F of x equals negative 2x. How else could I write that? Y equals 2x. Is that written in slope-intercept form? Yeah, it is. So therefore, you can see where that is 1. Agreed? That's the slope-intercept form line. And then here's the other one, right? F of x equals x plus 3 is the same as y equals x plus 3. You can see that they're still lines. Agreed? Do you see that? Okay. It's important that you see that you recognize that. If you recognize that, you're a long way to going toward this, but here's one. Let's take our graph. Let's get our graph guy out here. That's not what I want. Yeah. Okay. On that first one, let's graph it right now. Let's graph that first one. Y equals negative 2x. In order to graph these things, what do I need to know? The two things I need to know are slope and y-intercept. What's the y-intercept? 0. Cross at 0 here. And the slope is negative 2. Can I just, isn't this simple to do? Minus 2, so down 2 over 1. So here's my guy here. I'll try and do this. It's tough to do. We'll just do that for now, okay? Here's the deal. I need you to see this. There's the graph of this right here. Do you agree that I've done that at least close? I mean, like, okay, there it is. What's the rest of that line say? It says graph f of x equals, and then minus 2x, if x is greater than 1. What we're going to do is this. It's all of this line that we've drawn that is greater than 1, where x is greater than 1. Where is x is 1? That's right here. Do you agree with that? So now what we're going to do is this. I'm just going to draw this very quickly. You don't have to do it like this every time. I'm just going to show you. If that's where x is 1, the only part that they want us to see is the part that is where x is greater than 1, which means that all of this part of our line, they don't want to see. They only want to see this part. Does that make sense? So then, what we're going to do is this. We're going to draw our line, except it's going to be right here. And it's an open circle there. Why is it open? What does it say up here? Less than 1. Does it say less than or equal to? If it was or equal to, then we would make it closed, right? But it's all the parts of our line. Our line goes forever like this, right? Both ways, forever. They don't want that. They only want the part that is greater than 1, which is this part. Does that make sense? Does that make sense? Okay. So then, now let's graph the next section. Let's graph the next part of our piecewise-defined function, and that is y equals x plus 3. Where does this one cross the y? 3. What is the slope? 1. So then let's draw our line here. That's not very well done there. There we go. There's our line. Okay, there's our line. Now, what does the rest of it say? Where x is less than or equal to 1. So that on this line, the only part they want is the part that is less than or equal to 1. That's the only part they want. So where is 1 again? 1 is right here. That's this guy right here, right? So then the only part I don't want all of this. I only want the part that is less than 1. And notice that I have a solid circle there. Why is it solid? Because it's or equal to down here, right? It's or equal to. This is this, right? We graphed both of these. We graphed that. We graphed that. They're right here. That is a piecewise defined function. Now, what they always ask you to do, they'll ask you to graph it, then they'll also ask you to give it the domain and the range. What does the domain mean? Don't say x. That is not what it says. It's all the numbers that x can be, right? The domain means all the numbers x can be. What's the range mean? All the numbers that y can be. So let's look at this. What numbers can x be? Is there any number that x cannot be? Well, look. Let's look here. Could x be a billion over here? Could it be over here? Will this line eventually go over there and hit if I'm a billion over here? Well, it will. Okay, can x be negative a billion? Will this line eventually get over here to negative a billion? Yes. The only thing we have to kind of concern ourselves with is right here. Can x be 1? It can't be with this guy here, but what about here? If x was 1, isn't it on this line? Right? So do you agree that x is completely covered here? X is completely covered. Therefore, what is the domain? All real numbers, right? And is there any number that x can't be? Okay. What about y? Is there any number that y can be? Well, first of all, could y be 0? Is there any part of our line that crosses where y is 0? What about right there? Yeah, it is. Okay, so 0 is good. What about like negative 5? Of course, right here is 1, and over here would be another, right? I mean, okay, that's fine. What about here? What about 4 on the dot? Is that 1? 4 is on the dot. It equals it right here, right? 4 would be 1. What about 5? No. 5 is no good. 6, 7, 8, no, none of these. What about a million? No. See how these are going down? They're both going down. So could it be 5? Could y be 5? No. So what's the highest? What's the biggest number y can be? 4. So you would say then the range is y is less than 4 would be wrong. Less than or equal to 4. Y equal or equal to? Because that is solid. Right? That's a solid dot. It's or equal to. So you'd say the range is less than or equal to 4. Make sense? You guys try one of these babies. Try one of these bad boys. It's the sample on the bottom of page 263. That's a good one. It's a good one. You have to decide if that is, well, anyway. I'll tell you right now, they're written in slope-intercept form, both of them. Okay, so here we go. Do you see the two? You see the two? Right? No, that's not the way to do that. They're right here. There's one, and then there's the other. Are they both written in slope-intercept form? Yes, they are. So here we go. It goes y equals 2x plus 1 and y equals 3. All right, the first one, let me, kind of a mess there. The first one, 2x plus 1, crosses at 1, and it's a 2 slope, so it goes like that. Here's our line, right? There it is. But okay, what is the only part that they care about? What does it say? What's the only part they care about? Where x is greater than 0. That means that all the parts where x is greater than 0, that's it. So then that would be only this part, right? Does that make sense? Open circle there. Make sure you put an open circle there. That's where x is 0. You have that? You have that? The next one, it says y is 3. Where is y equal 3? That's up here. That's this guy. Only the part that is y is less than or equal to 0. Does that make sense? Your graph should look just like that. Open circle here, closed here. That's what it should look like. How many of you got that? Oh, that's not good. Do you see how it works, though? Do you see it now? I mean, okay. The domain, look up here. What is the domain? Where does it not go in each direction both ways? Does it go left and right forever both ways? Yes. So then the domain is all real numbers. What's the range? What's the highest or lowest anything could be? Is there a height? Is there a maximum? Can y be a million? Yeah. Okay, so then it's not that. Can y be a negative a million? No. Why? So then what's the lowest? Where's the domain? What's the range, I mean? Is 1. You would say that the range is y is, don't say 1, that's not true. Y is greater than 1, right? Now, why not or equal to? Look at this. That's an open circle. That is y is greater than 1. That would be the range. And on your test, you got to get it perfect. I don't give partial, you know that. I don't give partial credit for anything. You either get it or you don't. Okay, I'll give you another one. One more of those to practice, then that's it. All right, f of x equals 1/2 x minus 1 if x is greater than 3 and negative 2x plus 3 if x is less than or equal to 3. There we go. All right, here we go. Paying attention, watching. This last one for today. Tomorrow, going to give you a big quiz. I mean, we're going to cover everything. So you want to make sure you got this. There's one, and there's the other. Yes? Okay. Y equals 1/2 x minus 1. Let's go over here to our okay. Here we go. Y equals 1/2 x minus 1. Crosses at negative 1. The slope is 1/2. What's 1/2 slope? Up 1 over 2. It'll look like this. That doesn't look good. That doesn't look good either. Pretty close. Okay. But I don't like doing that. Okay. So where is the what's the only part that we care about though? Where x is greater than 3. That means it's only from right here that I even care. Right here's x is 3, so it's everything to the, this is all we care about is over there. So then I need to go open circle, everything else gets erased. Does that make sense? That's how I would do this. Does that make sense? You literally draw the line because notice it's not right here. It's not on the y-axis or the x-axis. It's, notice, what you should do is draw the whole line, figure out, well, they only want it from where x is 3, so that is this spot right, that's this guy over, so then it's only right there. That's the spot I care about. Everything else gets erased. Does that make sense? That's how I would do it. Okay? And then the other line is y equals negative 2x plus 3. That means it crosses at 3. It's a negative 2 slope, so then it's going to go like this. There's my line. And all they care about is the part that's where x is less than or equal to 3. Less than 3. Here's 3 again. They only care about this part. So then I need to erase. They only care about that part. That's this right here. And the rest of this gets erased. Does that make sense? Does that make sense? As long as it makes sense to you, then you're in good shape. I mean, like, draw your line like normal, and then you go, okay, on that line, the only thing they care about is this. Oh, on the other line, the only thing they care about is that. Draw your line, and then only show the part they want. Now, domain and range. Let's look at this. You got to get this too. Remember, you could get all this right and still get it wrong. What is the domain? Domain is all things x can be. All you have to do is ask yourself, is there any number that x can't be? Isn't it going that direction forever and that direction forever? It is. So, all real numbers. Is it going up and down forever too? No. Is it going up forever? Yes. So then what's the minimum then? What's the bottom of this thing? What's the bottom? Where what? Don't say 3. No, it's not 3. What's the bottom? What's the lowest thing that y can be? Can y be negative 5? Can y be negative 5? No. Okay, so what's the lowest thing it can be then? Negative 3. The lowest thing it can be is negative 3. Right? That's the lowest part of the whole thing. So then you would say y is greater than or equal to negative 3. Y are equal to? Solid. Right? Greater than or equal to negative 3. That's the only thing that y could ever be. Make sense? Okay. Question?
So it's closed solid dot if it's or equal to?
Closed solid dot if it's or equal to. Open, just like we used to graph. Remember we used to graph our little 0, 4, that would be, right? Remember these? Yeah. Okay. There's no homework tonight. Tomorrow I give a big quiz on this, though. Tomorrow we get a big quiz, so you're excited.